Shall I start?
Yes.
Good morning, good afternoon, and good evening to everyone joining us from different time zones. I am Soumitra Pal, a 2000 graduate of the Department of Computer Science and Technology at IIEST. Currently, I work as a staff scientist at the National Institutes of Health in Washington, D.C. We are in the midst of a revolution in artificial intelligence and machine learning. The success of systems like ChatGPT, which can learn from vast amounts of data and engage in human-like conversations, is truly remarkable. These technologies are transforming various aspects of our lives. However, when it comes to applying these technologies in industry or academia, especially in building successful products, many challenges arise. The answers to these challenges are not always readily available. Today's webinar is an earnest effort by the special interest group on computer science and data science within our alumni network to address some of these questions. We are fortunate to learn from two of our esteemed alumni who are experts in this field. This event will be shorter than our usual webinars, offering a quick overview of building products with generative AI. Our goal is to make this session engaging and valuable for participants of all expertise levels in AI and data science. Let me introduce our speakers for today. Mr. Chiranjib Bhandari is the CTO of Avanseus, an AI product software company specializing in predictive maintenance for communication networks. With 30 years of R&D experience in enterprise AI and telecom operation support system software products, Chiranjib has a strong background in mathematics, statistics, and software development. Chiranjib holds 8 US patents in machine learning algorithms. He is a 1992 graduate of mechanical engineering from our university and later pursued further studies at IIM Mumbai. Welcome, Chiranjib.
Thanks, Soumitra.
Mr. Avishek, thus, our second speaker is a data scientist specializing in AI and ML at Tata Consultancy Services. He graduated in 2022 from the Department of Civil Engineering at IIST, Shibpur. Avishek has a deep interest in mathematics and machine learning and has worked on multiple machine learning and generative AI-based solutions. Today, he has given his time to teach some of the things that he has learned. Welcome, Avishek. So we are thankful to both of our speakers for their time and generosity, and we are also excited to hear from both of them. Without further ado, I hand over the podium to Chiranjib.
Thanks, Soumitra, and thanks for everyone who has joined. I'll straight go to the topic and share my screen. I hope you can see my screen. So for next 20 minutes or so, I will take you through my experience in building AI products and use cases where generative AI is used. Okay, so the focus will mostly be on the use case, and what we see in terms of availability of Gen AI services, how they're useful in building an end-to-end AI product for a specific domain. What problem typically we face, how do we ensure the results are reliable. So those will be the kind of topics. If you see here, the topics which I wanted to cover, I'll briefly touch upon on technical essentials. Technical essential is just to set a background on which we could really discuss the use case specific considerations. Okay, so technical essentials will not go into details of technology involved, but as I said, just to set the foundation. We'll talk about, a purpose, how it works, embedding basics, typically the mathematical foundation of GenAI. And then we talk about use case specific considerations. And this is what will be based on my experience on building products, typically for communication service providers for predictive maintenance, and how we use GenAI capabilities in that, and what has been our experience in terms of customer acceptance, in terms of results achieved, in terms of reliability, which we see, and in terms of our experience in, making it, how do I say, acceptable to the broader community. So yeah, we will go into details. So in technical essentials, we will just cover, as I said, the foundational things. The purpose, before we start thinking that we will use Gen AI, we must have a very clear understanding of which situations Gen AI or LLM based solutions can fit properly. Because AI is just not, LLM. It has so many other algorithms, so many other areas. So I have listed 4 points here, which in my opinion are the criteria by which, we decide, that this is a fit case for LLM. So the first one is, if you see, generating well-formed content given a context, which is, people call it question answering. The fundamental is we have a context in terms of some textual information, or in terms of, images or videos. And from there, we have to create some idea, typically a content, okay? And the content should be well-formed, that means if you are creating English language, it should be grammatically correct and it should convey meaning. So that's one use, and that's, the predominant use. Second is also summarization. And summarization has many uses. And when I go through the use cases, you will also see summarization is, of course, we have, a combination of text, images, or videos, and we need to save or summarize what it is. The other requirement, when you go to enterprise application, is understanding meaning given a conversation. And it has, of course, we could argue that, to what extent this is mature to really tell us the meaning, but this is the objective on many use cases. When we talk about, call center applications, when we talk about the applications which I will talk about, we really try to understand, what is the meaning given a conversation. And the other one which we found is useful is the opposite of, given text. It is, we have structured content, and from there we want to generate well-formed English language or any other language. So that means we have a software which is generating some structured content like JSON or XML, but we want to convey to the user in his language, so LLM is kind of very good in creating well-formed text, correct? How it works, we will not go into detail, but we must understand the fundamentals here. So it typically generates sequential output given partial input. And this is not something which is absolutely new in AI. AI is actually started with associative memory, Hopfield networks. And of course, recurrent neural network has very long history in AI. Both of these and many others, are actually serving this kind of purpose, that, if we give partial input, can we generate output, or can we generate the succeeding part of it, So it is just a kind of sequence, and we just keep, let's say some part of it and what is following that, okay? Of course, it has to be structured in a very nice way, and that is why LLM works, how do I say, so sophisticated way, because it has been structured in that way. But the fundamental is like this. And the crux of this is, it is a memory mechanism, but it must have strong generalization capability. So it is just not that, it should be able to remember something, but it should also be able to approximate, which we call generalization capability. We're not going to detail, how generalization is measured in terms of mathematical construct, but it must be able to generalize, to be one line answer to generalization is that state space curve should be smooth, okay? But we're not going to detail, but this, so it is actually a memory mechanism with a generalization capability. And if you see the current generation of LLMs, they're very smooth and they look very smart from outside, that is because they also apply a lot of post-processing like RLHF, reinforcement learning from human feedback, similar kind of techniques, so that it really emulate, English language or emulate somebody's preference and all of this. So this is how it actually works. And now embedding is something which is very important, and not many people may not understand this, but embedding is at the heart of how do I say, all these text-based analysis techniques. Unless we are able to encode this, text in the first instance correctly, we will not get correct result. Again, embedding is a mathematical term. So, okay, embedding is not a term which is generated in AI. Embedding is generated in topology, mathematical topology. Embedding means mapping between two spaces, okay, and typically manifolds. And the mapping is very specific, one-to-one, on-to continuous and differentiable. So when we say embedding in language model, what we are saying that we will embed or we will encode English words or English sentences in such a way that it will be continuous. That means two words which are similar meaning, they will have similar encoding, correct? Continuous means it will not abruptly vary, So now embedding spaces are typically Euclidean because, we do not want to confuse people, by asking them to use a distance measure which is complex, like geodesic distance. So we want to have Cartesian distance. That is why it is an Euclidean space. And it is typically derived using large corpus of text. So how do I understand that two words are similar or two sentences are similar? Of course, there are many ways, but the simplest way is that they are occurring together and, they are occurring in the same context. That means, so that is why it is derived from the large corpus of text. But again, we should remember that embedding has almost nothing to do with this vector-based representation in reality in, humans or other animals, because at neuronal level, we do not have vectors. In neuronal level, it is, neuronal assemblies. And it has been experimentally found in neuroscience, theoretical neuroscience, that this embedding happens because of overlapping neuronal assemblies. So that means when we are seeing a river and water, these two neuronal assemblies are actually overlapping. That is why when one gets activated, another also gets activated. That is the physical implementation of embedding in living animals, okay, living bodies. Now we will quickly go through, some use case specific considerations. Now, again, where this kind of functionality will be needed, when we need to take decision based on ill-formed text or approximate similar situation. So in some case, we know that, the English sentences are not correctly given. If let's say we see doctor's prescription, or we see, somebody has done some repair work, he or she will not always write fully correct English, or he will not complete sentences, they will use jargons, they will use abbreviations. So these are ill-formed text, So if we have to take decision in an automated way from ill-formed text, is a fit case for LLM usage. Another fit case is approximately similar situations. So that means, we need to decide about something, but we do not have absolute, same situation to derive the result from, but we have a similar situation. So how can we, derive a result from that? Again, there is use case which will, use this idea that how do we approximately match situations. And the second one is, which I earlier mentioned, that we have the opposite requirement, that we have structured text, structured data, and we want to create well-formed texts. Okay, so that now the LLM is given as a service, as you all know, correct? But that service will, of course, need a lot of considerations before it gets used in a commercial product, which is usable. And that is what, I will take you through next two slides. What kind of adaptation is needed? The first adaptation is you will almost always need new embedding for domain-specific keywords. And it's almost always the requirement. If you see here, we work in telecom softwares, and everybody knows BSc in telecom software is base station controller. Okay, it doesn't need any explanation for telecom softwares. But out of telecom software, BSc will always probably mean Bachelor of Science. So if we simply use an LLM trained with internet grade data, then we will always fail, to approximate situation, to approximately match, because these two meanings are totally different. Similarly, just not what, even concepts. So as I said, let's say river and water is connected, from standard thinking, correct? But if you see here, in the area where we work, equipment faults are typically related with high temperature. It's not only in telecom, maybe in other industry also. But if you think of normal English literature, based on which the LLMs are trained mostly, fault has almost no relation with temperature, because it's a kind of specific situation, where temperature and faults would have similar embedding, correct? So this is a fundamental requirement, that when we use industry-specific use case, we must regenerate embedding using the keywords and concepts from that domain. Okay, and every domain has this kind of thing, correct? In medical, of course, there are so much of acronyms. In telecom also, there are so much of acronyms. In other areas similarly. And just to give you some example, I put two screenshots from our activities. If you see, we are trying to see, let's say in telecom, we call it cell, correct? GSM cell. So if I try to approximate cell degraded, see, it has automatically found out critical temperature functionality decline. So this means the embedding is working correctly. The changed embedding which you have done, so it automatically understands that this is related with this. Similarly, in a electronics equipment, if a card is down, the device will get isolated. And see, since the meanings are related, it has automatically understood that these two are related. If I just have English novel-based training, card down has nothing to do with isolation of device. They're just, how do I say, independent. They're parallel. So this is something which is a requirement. Okay. So there are two use cases. Time is less, so I'll go a little fast. There are two use cases which I'll take you through. One is, when an equipment fails, we need to look up a knowledge base, compare the current fault conditions with entries in knowledge base, and provide the underlying root cause. So the problem is, a machine will fail, and it will emit some alarms, or it will emit some performance counters and all of this. And we have some knowledge repository, not just from that machine, and from some other machine in the same domain. Now we should approximately match, that, okay, it has emitted this alarm, it has shown this kind of trend. So what could be the root cause? As you see here, in fact, these two screens also, you see similar situation. It has come with this, and it is trying to match in an approximate way. So this is the simplest of case. The typically equipment doesn't fail with just one alarm, correct? It comes with a a list of or a set of correlated alarms, and we need to all match all these things. But this is a real case of approximate matching, and it has huge value. If we just say that root cause as in a wrong way, then this whole process will get disturbed, because there will be some automated command firing to an equipment which is wrong, or there will be some person who will be sent to solve this problem in a wrong location. All of this will get into problem. Okay, so this is hugely important, that this approximate matching goes almost always correct. Okay, so this is one use case. Second use case is, now for this earlier use case, provide a recommended action. We understood this is the root cause. Now what somebody has to do to solve this problem, that depends on what kind of action has been taken earlier. And when people take action, as I said earlier, that they will not write correctly. They will just write, I close the ticket by changing cable, or they just write cable changed, or they just write cable. They won't even write changed. Okay, so by seeing these earlier actions taken, how can I say now that what is the next action? And those actions are, as I said, they're in different languages. They're not in one sentence. They come in, many different sentences, many different emails, all of this. How can I take this? And it typically always happens in a sequence. We maybe first action will be some replacement of consumables. Second time they will replace cable. Third time they will replace parts. So we must know at which situation we are in. If we are in this situation, then we should suggest this, correct? So understanding from an English language that we are in this situation, that should happen through LLM based analysis. Okay, and now what has been our experience on using LLM, and how do I say, what kind of configuration is typically needed. Now think of this situation which I just told earlier, that we cannot give an LLM an unconstant situation. If we say that, okay, and we are saying here, if you see, so these are the list of solutions given to a telecom operator if the device fails, that in network operation center, you take this action, and in field, you take this action. Now, last action was this. Now tell me what is the next action. Okay, if we give this, then it may tell correctly, because you are guiding the large language model in many ways. You are just giving him the context that these are the typical actions, this is the typical sequence, and this is what we see now. Now based on this, tell me what should be the next. Okay, and so that means when we generate the prompt, we must be considering all of these constraints, and we must be constraining as much as possible, so that it gives what we want. Otherwise, it will give a generic thing, and it will never work actually. Okay, so this is one learning from our work in LLM, that a prompt should mention use case specific constants. And you see here, we even write that if an action has already been taken, don't ask the same action to be taken. We might have replaced the cable last time, so it should not again tell that you go and replace cable. It should say that, okay, now go and replace the part. So it must automatically understand or consider all of this, correct? So we see here, we have written note, previously taken action must not be taken again. So this is a learning that we must constrain as much as possible. Second learning is, see, this is an automation. We must get an output in a format which we really need. So, and format means we're not talking about how many bullet points. We are saying that it should be grouped properly. So in this case, we have very clear requirement. Some action has to be taken on network operation center, which is an office kind of environment, and some action people have to go to the equipment, site, and they have to fix something, correct? So it must give us two answers: what has to be done in network operation center, and what has to be done on the field, if you see here. So we must also ask LLM that give me this format. Don't give me in some way that, okay, do this, because that will never work. So this is something specific configuration And this, of course, has to be generated in an automated way from the software, which I will talk again. How do we improve reliability? I already talked a little bit, but here it is again. Forcing LLM to provide response from one among options supplied in the prompt, so that we avoid infeasible options. So this is something which is very important. If we just say, tell me something about this problem, what has happened, we will never get result. Okay. If we say, tell me whether it is an electrical problem, mechanical problem, or some other problem, we won't get correct result. If we say, okay, I have this list. It is a cable problem, it is a card problem, it is a temperature problem. Tell me now, which is the problem you identified from this English text which has been given to you. That may give us some result. Okay. So we must always think of giving options so that it doesn't give an open-ended answer, which will not solve our purpose. And another thing, another learning from this kind of software is that, see, if you give a 2 pages text and you see and you ask it that, tell me, did you see some card problem, or did you see some temperature, or did you see some other problem in this, it may not give you correct result. The way to do it is, first, these 2 pages should be summarized into a single or 2 sentences, and then again summarize that or classify that into a final one. Okay. So that means you are allowing that LLM software also to work in stages. Okay. But maybe going forward, LLM will be smart and they will do it in single stage. But for now, we have seen that if you summarize in successive steps, then the accuracy improves. Okay. Now, some practical considerations when you integrate with LLM services. Of course, LLMs are available as services, we know this. So LLM is still not very real time. Okay. Of course, you may say that, yeah, it gives me in some seconds, but in industrial situation, some seconds is also not tolerable sometime. If you are doing a drone control and some security issue has happened, that means some let's say a lot of traffic are going in the path of drone control, let's say management information path, then we will lose the control of drone, correct? Because some attack has happened, DDoS kind of attack has happened. So in that case, if we have to initiate an action, we must initiate an action in 1 or 2 seconds. So we cannot depend on LLM that, okay, it will give me in less than a second, and then I will give a response back and I will initiate an automated action. Okay. So what we have seen is that we should avoid real-time LLM usage whenever possible. That means we must have enough time in hand, or we must be able to do something before this kind of situation happens. Okay. But we should see what is the reality of the use case. And of course, as I said, automatic prompt generation based on configuration. You saw this is the prompt, correct? And this is the response which has come. So this prompt should, of course, always be automatically generated with all the constraints which we just discussed. Okay. And now, yeah, so this is our eventual experience on actual usage. Okay. So what we see is that majority of the work is involved in automation pipeline. Okay. And that this will of course depend on your experience. Typical stages in our case, let's say, where we are analyzing some earlier ticket and we are trying to understand what action has to be taken, it involves, we actually have this translation problem, because in different countries people will write in different languages those tickets, so we must translate it to uniform, make it uniform first. Then we apply summarization, then we apply classification, and then we apply response generation. And this pipeline, of course, has to be automated, because it will happen in a real time, kind of near real time situation, correct? So a lot of work is involved in this. And also, based on our experience, substantially work is involved in validating results with real data. And this is very, very important, especially in situations where where we work. And as I just mentioned, that we cannot be wrong in understanding a root cause of a problem which has happened in the telecom network, correct? Because we will just incur huge amount of cost, and we will incur huge amount of penalty in terms of government regulation, violation, all of these, correct? So we must be validating these results with real data. And this is where all these complexities will come. And that, all kinds of checks has to be done. All kinds of constraint has to be put on the LLM output. And we must satisfy ourselves before putting into production that, this will not go other way because it has huge repercussions. Okay. So this, I'll stop with this, and maybe I'll take questions later. But this is what we wanted to tell you, based on our experience, how to use LLM in a situation which is critical, which is just not, talking something, and if something goes wrong, nothing will happen. Okay, it's other than that. Okay, yeah. Back to Soumitra.
Thank you, Chiranjib. You gave very interesting example of where we can use LLM-based solutions. So actually, while you are explaining this, some questions came to me in my mind, and I also see some questions are there on the chat. But we'll wait for the second speaker to finish, then we'll go for the chat. To the audience, if you have any questions, please send it on the chat. And at the end of the second speaker's talk, we'll address those questions, some of the questions based on upon the time we have available. So please write on the chat your questions. So since we are running a little late, so we'll directly go to Avishek's talk. Please, Avishek, you start.
Yeah, thanks. Let's share my screen. Yes, my screen is right.
Yes.
So, hi everyone. This is Avishek. So, currently I'm working as a GenAI and AI/ML developer at TCS. I graduated from civil engineering department. So till now, Chiranjib gave a great introduction and explanation to different technical aspects and to aspects of GenAI. And now I'll be giving a brief about one project that I have worked on personally to solve a problem, like solve a specific situation. And there I have used generative AI. So the problem was here, like classifying the text contextually. So, like normally in machine learning, classical machine learning or deep learning, what we do is like giving a text and classifying those into some different classes, right? Uh, so any person who is having some know some exposure to machine learning will try to solve it with classical machine learning problem as a classical machine learning problem. But the problem is when you are having very large number of classes and very less amount of training data, then the actual problem comes, and you can it will be very tricky to map those text and train your custom models. So at that time we have to move to gen ai, because GenAI is already trained on a huge amount of data, and possibly it can give us a great results without doing a custom model training with with very less data and getting a bad results. So the main reasons for using GenAI was, first of all, it is like multilingual inputs. The use case was, classifying some questions and assign them some tags. So the questions can come from multiple segments of, multiple countries, right? So they might have some different languages. So training the custom model with multiple languages is again a problem. Then large number of classes, as I described, like for training a large number of the classifier for the large number of classes, it might need, or it needs very huge amount of data. Then less training data, that's kind of a you know a, a single problem for our like single reason to move to GenAI. And then the handling the human error. So whenever someone is asking some questions in the portal, right, they might have did some grammatical errors or maybe spelling mistakes, something like that. So those can be handled very efficiently with generative. So I'll now describe a brief about like how is the architecture. First, when someone asking a question on the portal, then we're taking the questions and we are having a knowledge base. Knowledge base is a vector database where those small training data what we were having previously, we stored those into the vector DB with after doing the embedding. So the new chat is coming to us and we are setting that to knowledge database or knowledge base. Then it is giving us the similar documents or similar examples, right? So these similar examples are already summarized with LLMs and then stored into the knowledge base, right? So whatever we are getting, these similar documents are already summarized. And with those similar documents, we are also storing the actual tags that are there for our training. Now, those similar documents are being sent to the dynamic K-sort prompt. So I'll go a bit the detail. So the prompt looks like first the personal definition of the LLM, then chain of thought instructions. There I have given some instruction like how to follow the process for tagging the tagging the uh, those text or questions coming. Then the main part is dynamic case sort examples. So normally the case sort prompting technique is like give some of the examples with the along with the prompt and the new queries, then ask the LLM model to give the follow that pattern to give the response. But as we are having a large number of classes, let's say we are having hundred or thousands of classes or tags, right? Then it might be difficult to give thousands examples to the LLM and ask the questions. So at that time we combined the RAG with keyword prompting and give relevant examples only to the LLM while we are asking for the tag of the new query, right? So those similar examples will be sent with the prompt each time we are asking for a tagging of new query. Then the next part is the query, whatever is being asked in the portal right now, and the output formats and the output levels. So the output formats are like in which format we want the output. It may be JSON, maybe XML, maybe any other format, right? And the output levels are the number of tags available to us, or we are trying to classify those texts as per these levels. Now going back to the architecture, then this dynamic case or prompt will be sent to the large language model. So once this model is having some generation, it will send us the output as a JSON format, and this JSON format will be so basically the output will be a stringify version of a JSON, and then will be parsing that JSON string to different tags. And you can see like these questions: how can I build one RAG system with LangChain? It is tagged with generative AI tag, right? Except of web development or blockchain or cloud computing or kernel or something like. So this is a very high level overview of the architecture I have developed. Now going to the some problems that we faced during the development. So first is the hallucination. So if we go by normal case out of zero sort prompting, then it might hallucinate and give you some bad results in case of some HGSS, or maybe where the model is not specified in that domain. So for that, what we did, we used the dynamic case out prompting with RAG. The next problem is output parsing. So normally what we faced, like the LLM was giving uh, like with only the stringify version of the JSON or the string, it was giving some other text. So parsing that data or the output as a JSON or dictionary was a bit of tricky. So for that we have developed our own algorithm to parse multiple JSON objects in the output of a LLM. Then the next was inaccurate document retrieval. So we are retrieving those documents from the knowledge basis, but it's totally depends on the embedding, right? As Chiranjib already told that like embedding is hugely depends on in which domain you are working. So for that we have fine-tuned one embedding model with our own data of the domain I was solving the problem, and then that inaccurate document retrieval was solved. And next to start any small, start with some small AI project, basically, first start with a very small problem or with a specific goal. Then maybe you can check, like, before solving any AI problem for community or for your own product. Basically, just check if it is adding some value or not, because once you have completed your project and then if it is not adding any value to anyone's life, then probably uh, mm, maybe like that product, most of the people will not be using because it's not adding some values. Then go with, like, do a bit of study of research works that have been performed, like done in the recent times, and some techniques which are working for others for a similar kind of a task, and then evaluate some of the top approaches what people are following, and then evaluate those to uh, like assess like which technique is performing better for your use case. And if we want to go with some free or cost effective ways, it will be like use some open source platform like Kaggle or Colab for embedding, fine-tuning, or maybe some GPU intensive tasks. Then go for free models or API that if your data is not too much sensitive, then probably you can go with free models, or you can try with some APIs which are very less, charging very less for a million of tokens or something. And then instead of going for directly to fine tuning or some that kind of approach, please first try with prompting. If it is giving better results, then probably it will be a good solution. If it is not, then go for fine tuning also. Yeah, so that's everything from my side. So over to Soumitra. Thanks.
Yeah, thanks, Avishek. So while we are waiting for others to write their questions, so so both of you gave some examples where you are using LLM, like the based service. So the portion that what coming to my mind is that there are different ways you can use LLM. Okay, so one thing could be that you are taking the decision itself is being made by the LLM, or it could be that the decision is coming from some other AI based solutions, just to interact between the user, the from which is always happens in the like human languages like English, Hindi, or whatever, and to convert that to input and output format that is familiar with your AI system. So there you can use LLM as just like a translator kind of thing. So my questions to first to Chiranjib Da, so which part of your in your software stack, like which part you are using LLM for? Is it for decision making, or just taking the outputs from the another AI system? You are using LLM as the translator between these two.
Yeah, thanks. So, yeah, no, it is in our case, it is actually for decision making. But yes, I will also talk about the other part which we are considering. So in our case, okay, it's one use case which I just described is actually part of a bigger use case. Bigger use case is predicting fault and providing root cause and recommended action. So predicting fault is AI which we have created, okay, which is not on Gen AI, which is our inventions on recurrent neural network and temporal dependency, all of this. So that is one part. Second part is how to understand what is the root cause. We may be able to predict a fault, okay, that this fault is going to happen in in next 7 days, but we have to also say why it is happening. So for that, we of course use a combination of our invention and LLM, but LLM is still on the decision making side, because as I said that from our other inventions, we automatically identify that when this fault has happened last time, what all alarms came appear. So we automatically cluster them. We have an fault cluster discovery algorithm which will cluster that. But after we cluster that, then we have to approximately compare this cluster of alarms with some set of alarms which is there in the knowledge repository, which is, typical retrieval augmented generation. Okay, so we will compare this, and based on that, we will understand, get a root cause. So this is purely on the decision making side, and it has huge importance, as I just mentioned. If that root cause goes wrong, we are wrong. We are basically, we have failed in that, prediction, basically. Okay. So yes, to answer your question, we are in the decision making side, but on the other side, also, we have not done it, but we are planning to do it. We also have to give some human, nicely, well-formed English that, okay, this is what you have to do based on many considerations, correct? So there, yes, we are planning to use LLM, which will be generating English based on structured text, correct? Because we already have structured text from other side. Yes.
That makes it more clear. So one thing I have as I read more and stuff. So this LLMs requires a lot of data, right? So in this case, like when you are using LLM for your decision making, how are you getting this data, huge amount of data? Because if the data is less, it will hallucinate. And so to make sure that it doesn't hallucinate, you have to give more data. So how do you tackle that part?
Okay, yeah, so this is a known situation, correct? But yes, in our case, I can only answer for our case. In our case, we actually have data, okay? And we have data because we have been working with many prospects, not all customers. And just to give you an example of the volume of data, we have worked with more than 60 telecom operators across the world, in terms of proof of concept and maybe 10 commercial deployments, but we have those data. So we, in our knowledge repository, of course, we have kept in anonymized way. Okay, we have, because these are, hugely debated, and we cannot show them, or we cannot keep their data logically. So we have anonymized the data. Anonymization itself is a big challenge, because here anonymization has to be in such a way that we do not lose meaning, correct? Because we cannot lose meaning, if I anonymize. So that is another problem which we are not describing today. But yeah, so we have this data, and there are a lot of other details. Since you just made this point, so I'll talk some of these details. So, it is not only that, I can take data from any network, because networks are also dependent on which weather condition they are working on. Okay, so US weather condition is far different from Middle East, where temperature is really, really high. So we actually classify those based on weather condition, based on equipment vendor also. Like, in telecom, there are a lot of equipment vendors, Ericsson, Nokia, Juniper, Avaya, Cisco, all of this. So when we do this retrieval augmented generation, we of course first apply all these filters that, okay, this current situation relates to, geography, which is in Asia Pacific, and it is, this kind of equipment, let's say Cisco equipment, and so we narrow it. Otherwise, it will, match with everything, and it will create some kind of problem. Okay, and how do I say, the important thing here is that everything should be automated, correct? Because this whole thing is automated, correct? If problem happens, we must do it in an automated way. So we must classify it before this, and it should automatically select a particular region. If customer is not there in a region, what is the nearest region? All of this actually happens. Okay, and that is, after that, the result will be good. So you are absolutely correct. The result will not be good if we just take some generic repository and do it. And yeah, so it has a lot of things on the back, actually.
Yeah, I think this addresses the question that has been put on chat by Hassan, whether do we train the model or use a RAG. From your description, it turns out that you use RAG. Okay, so similar question might go to, do you see, Abhishek, do you also see the need of large amount of data in your project, or like what is your opinion about amount of data that you need for your project?
Yeah, so like as I described that, like the main starting of our project to like use Gen AI for the solution is like having less amount of data. right? And the huge number of classes. So for train, like if we go by classical methods, then we would have needed some more amount of data for those huge number of classes or tags. But as we are going with generative AI, and that domain was kind of generic, like coding domain or maybe IT or programming domain. So it was like we don't like we are not able to get that amount of data, and we have not trained the model from the scratch.
Yeah, so I think what I understood from your discussion, like, so yours and Chiranjib have slightly different applications. In case of Chiranjib, he's building the LLM from his own data. But in your case, what you are doing, you are using a pre-trained LLM from some other source, and you are fine-tuning for your purpose on a limited amount of data. Okay, so yeah, I think this makes it clear. Now, there is one question on the chat. I think what he's trying to, from Hassan, he's trying to say is that, so when you are using this fine tune for your task, did you do any kind of comparison with your traditional ML based, and what was the kind of accuracy improvement that you see using this LLM? Because this may motivate other people who are using traditional ML classifications algorithm. If they can use this fine-tune approach, then they may get better accuracy. So that if you can give some information about that, that will be good.
So like when anyone is trying to train, I would have like told, if you are having data, then go for training. That one thing. Then like for the experimentation, we tried with that data we were having at that time, and got approximately 65 to 70% of accuracy, for multi-class classification. Then when we moved up to around approximately 80% for the classification of accuracy when we integrated generative AI with the solution. That kind of accuracy jump we got after. We
There
were,
is, yeah, there is a question from Kalpana D. I think it is addressed to Abhishek. You mentioned that there is evaluate multiple techniques. So can you please share mostly used techniques in LLM? I think she is trying to say like what are the different techniques from LLM that you have used and evaluated.
so like multiple types of or multiple techniques in the sense like some for building Gen AI solutions, like there are some patterns of architecture that normally people follows. So if you go by just prompting, there are two approaches, that is zero shot and few shot prompting. And then if you go by like if you go by adding some more complexity to the architecture, that you can include vector DB and RAG concepts. And after that, if you are not getting that much expected results, then further you can go by fine tuning. Like these are the some famous or generic pattern that people follows for their GenAI solutions.
Yeah, I think we are already on oversitting time. That we are supposed to finish at 11:15, but we went. But anyway, thanks to both of you for providing sharing your experiences, and I'm sure you will be both available for any questions that others may have. So if I tell them that LinkedIn is the best approach to connect you, is that good? That if the audience has some questions, they can go, and if they
Yes.
need further help in applying LLM techniques in their areas of your domain, if you are willing,
Yes.
you can.
Yes.
Yeah. So with this, we had a great session, and we had two great speakers, and we saw multiple applications and different scenarios in which you can apply LLM based techniques. And with this, I'll close the session now, and thanks again. And thanks to
Excellent.
all of the audience who
Thanks,
joined.
thanks.
It was really helpful.